Hello friends, welcome to today's lesson. Today we are going to look at ionic and covalent bonding. Ionic and covalent bonding. Of course, a bond is an attraction that exists between two or more atoms. A bond is an attraction, it's a force of attraction that exists between two or more atoms. And we have two types, ionic bond and covalent bond. Now let's see the properties of ionic bonds. Ionic bonds involve transfer of electron. Any bond forms when an atom gives up an electron to another atom, creating a positively charged ion, cation, and a negatively charged ion, anion. So the first feature of ionic bond is that there is a transfer of electron, normally from a metallic atom to a non-metallic atom. Then when that happens, there is an electrostatic attraction. It's a force of attraction that exists between these two ions. That force is called electrostatic attraction. And the compounds that are formed through ionic bonding have high melting points. They have high melting point and they are conductive. That is, they conduct electricity. Okay, so let me go over that again. Features or properties of ionic bond. The first is that it involves a transfer of electron, normally from a metallic atom to a non-metallic atom. The second is that there is an attraction that exists between the ions. Okay, and that attraction is called electrostatic attraction. Electrostatic attraction. Now, the compounds that are formed through this bonding have high melting point. They have high melting point, and they are conductive. That is, they conduct electricity. Okay, now let's see covalent bond. What are the features of covalent bond? Here there is a sharing of electrons. In covalent bonding, atoms share electrons to achieve a stable electronic configuration, creating a molecule. So this involves the sharing of electrons between two atoms, normally two or more non-metallic atoms. Now we have three types of covalent bond based on the number of electrons that they share. We have single, double, and triple covalent bond. Single is a case whereby the two reacting atoms contribute one electron and then share the two electrons between them. Double is a case where each atom contributes 2 electrons and they share the 4 electrons between them. Then triple is the one where the reacting atoms contribute 3 electrons each and they share 6 electrons between each other. Now, what are the properties of covalent compounds? Covalent compounds generally have low melting and boiling points. They have low melting and boiling points, and they exist as gases or liquid at room temperature. Now let's see some properties that enables bond formation. Talking about electronegativity and bond polarity. Electronegativity is the measure of an atom's ability to attract electrons in a chemical bond. Okay, if an atom is able to attract electron more than the other in a chemical bond, that bond is going to be ionic or polar. A polar bond, if the electronegativity difference between two atoms is significant, the bond is polar. Now, with one atom having a slightly negative charge and the other a slightly positive charge. Then if for non-polar bond, this occurs when the electronegativity difference is negligible. When the electronegativity difference between the reacting atoms is negligible, the bond form is non-polar. Now let's see a comparison between ionic and covalent bond. Type of bond: ionic, electron transfer or sharing. Ionic bond involves electron transfer. Then talking about the melting point of the compound form. The compound have high melting point. Then conductivity. Do they conduct? Yes. Ionic compound conducts electricity when dissolved in water or when it is melted. Now for covalent compound, do they share electron? Yes. It involves electron sharing. About melting point, they have low melting point. Do they conduct? No, they do not conduct electricity. Now let's see everyday example of ionic and covalent compounds. We have first sodium chloride, a stable salt made up of sodium, that's made up of sodium chloride. It's a common example of an ionic compound. We have sugar. Sugar is a covalent compound and it's essential for our energy and plays a role in many biological processes. So we have water. Water is a covalent compound and it's crucial for life and essential for many chemical reactions. Diamond is a covalent compound, a covalent substance with strong bond and is known for its hardness and brilliance. Okay, let's review what we have learned. Ionic bonding. This involves the transfer of electrons between atoms, forming ions that attract each other. Covalent bonding involves the sharing of electrons between atoms, creating molecules with strong bonds. Electronegativity. This helps to determine the polarity of a bond based on the difference in the electronegativity between the atoms. If the difference is high, the difference in the ability of the atoms involved in a bond, if it is high, then that bond is said to be polar. If the difference is negligible, then the bond is said to be non-polar. And we have ionic and covalent compound. Ionic and covalent compound have distinct properties that make them useful in various applications. For ionic compounds, they have high melting point. They are conductors of electricity in molten form or in aqueous form. Okay, and they are soluble in water. All right. Then for covalent compounds, they have low melting and boiling points, and they exist mainly as gases and liquid at room temperature. Okay, we are going to take some likely questions on this topic, so stay on. Welcome back. Now let's take some questions on the topic that I have just treated as ionic and covalent bonds. This is a checkpoint examination question of 2023, April 2023 question. Question 1 says, the diagram shows a model of a hydrogen molecule where X represents electron. Name the type of bonding in a hydrogen molecule. This bonding is covalent bonding. The bonding here is covalent bonding. And the next question says, explain how you can tell from a distance or from the diagram. How we can tell from the diagram. Okay. The diagram shows that the two electrons are being shared between the two reacting atoms. The two electrons are found in the common boundary, that's the overlap between the two electrons. So those electrons are being shared, and covalent bonding involves sharing of electrons. The next question says, look at the diagram showing a chlorine atom and a chloride ion. Okay. You can see chlorine atom, Cl, and chloride ion, Cl minus. Describe how a chloride ion is made from a chlorine atom. Describe how a chloride ion is made from a chlorine atom. Now, let's look at the outermost shell. That's the last shell, the test shell of chlorine atom. The test shell contains 7 electrons. 7 electrons. And let's look at the third shell of chloride ion. The third shell contains 8 electrons. This additional electron represented with a dot on the third shell. So the third shell contains 8 electrons. So it means that a chloride ion is formed when a chlorine atom gains an electron. A chloride ion is formed when a chlorine atom gains an electron. So we're asked to describe how a chloride ion is formed or made from a chlorine atom. So a chloride ion is made from a chlorine atom when it gains an electron. The next question says sodium chloride is made up of sodium ion and chloride ions. Explain how the ions in sodium chloride are held together. The ions are held together by an electrostatic force of attraction. Electrostatic force of attraction. Okay. Next one says sodium is in group 1 of the periodic table. Sodium reacts with chlorine to form an ionic compound. This ionic compound contains sodium ions and chloride ions. Why is a sodium ion positively charged? Circle the correct answer. Okay, the correct answer is the last one. A sodium atom loses an electron. That is why it becomes a positively charged ion. It loses an electron. Let's see the next question. Elements and compound either have a giant structure or simple structure. The table shows the table shows information about 5 substances. Complete the table to identify if the structure of each substance is giant or simple. Okay. The first substance has a low melting point and low boiling point, and it does not conduct electricity. Okay, for a substance to have a low melting point and a low boiling point, it means that substance has a simple structure. Okay, like gases like hydrogen gas, chlorine gas, oxygen gas, they have simple linear structure. So the structure of the first compound or substance J is simple structure. The next substance K has high melting point, high boiling point. Does it conduct? Yes. Okay, this is likely going to be an ionic compound because the bond that exists between ions in ionic compounds are strong bonds, what we call ionic bonds. So ionic bonds requires very high temperature to break them. So, and these substances have giant structure. They have giant structure. So for substance K, the structure is giant. The next substance L has low melting point and low boiling point and does not conduct. Okay, this is likely going to be a substance that has a simple structure. So this has a simple structure. Substance M has high melting point, high boiling point, and does it conduct? It does not conduct. This is a substance that has a giant structure. Remember diamond? Diamond is a substance that has a giant structure. It is the hardest substance known so far, but it does not conduct electricity. So this substance has a giant structure. So M is giant. The last substance has a high melting point, high boiling point. Does it conduct? No. Does it conduct? No. Okay. This is also a giant structure. The substance has a giant structure. All right. Thank you very much. Have a nice day. Bye-bye.